very bit stressed as well, because I'm trying to, I worried that I may miss some of the very valuable informations, and which might be very useful to you. Okay, I hope that you can follow me, where this might give us some good visual understanding why we should learn the vector, because vector required, as I say, is required good visual understanding. If you don't understand, we don't be able to visualize the problem. It's very hard for us to solve the vector problems. Therefore, now with this, I have done what we call the definition of vector. Okay, now in simple, why do we need to learn vector? Vector will give us the detail of magnitude and direction. Therefore, I able to see the progress or the movement of the object. And if we incorporate tensor, okay, if we embed one more information called transformation, therefore we able to bring the vector into another state, whereby we able to see the interaction of the object in any space. Therefore, can we see now there is some beautiful progress in the understanding of any particular object in what we call as in the space. Therefore, I call it this as a dimensional thinking. Therefore, what is vector? Vector is a dimensionally placed object, whereby we can able to see the magnitude and direction of that object. Okay, now let us move into another detail, what I call it as a unit vector. Okay, unit vector. This is one of the very important property of the vector. Okay, why we should learn vector? Okay, the property of this unit vector. Okay, unit is the smallest unit which will be used to measure any object. Okay, this is the smallest unit, the quanta of any particular measurements in the vector, where we can use to measure the object. Okay, this unit is one of the smallest unit. We can write this as a V with a cap. I'll put it that as a cap. It's not a arrow. Okay, we call it, this is a smallest building unit, of any measurements for the vector. This can be explained as with the cap, as I said, and we just take a vector and the magnitude of the vector. We just divide the vector, the direction of the vector, with the unit of, the magnitude of the vector. Therefore, let's say, if I call it a V, the arrow is a AXI, AYJ, AZK, okay, and okay, we should able to write that as this. Okay, AXI, AYJ, AZK, divide with the magnitude, AX2, AY2, AZ2. Okay, the square root of this. Okay, now simple question to ask, what is this I, J, K? This I, J, K is actually, it's a unit. J, K are the unit vectors. Okay, unit vectors. unit vectors. These unit vectors will explain the direction, okay, the direction of the units, the vectors, and of the location of the particular object. Okay, now with this unit vector, now we should able to look into more detail. Okay, if this is a 3D, three-dimensional vector detail, is it possible for me? Okay, I missed this detail here. Okay, let me put it here. Okay, for the y and x here, can I visualize it any particular, is it possible for us to visual any particular direction of the objects with this, what we call as let I j be the unit vector. This is a 2D view, 2D view. Let us visualize this problem in a 2D view, and this is the progress of the v, and the v, we call it this in a vector component. The vector component based on the what we call Cartesian coordinate system. Therefore, we able to address the Cartesian here as a vxi, vyj. The I and j, as I said, is the smallest building unit in the direction of x, and j, for example, I here is in the direction of the x, and j is in the direction of y. And for the 2D is a very obvious when I taking the magnitude of this two-dimensional vector. This is a vx2 vy2. Some of you may ask, why are we using this is actually is a theorem Pythagoras. Okay, this magnitude basically is we are trying to identify this is a vx, this is a vy. Therefore, when we combine the vx to the vy, we get the detail of, or the magnitude of this vector. Therefore, it's a very simple idea. When you wanted to identify the magnitude of any particular vector, you are required only to identify what we call in a simple theorem Pythagoras. We need to use a theorem Pythagoras to identify the magnitude of a particular vector. And what about the 3? When you started observing this 3D in a 3D form, okay, in the 3D form, usually we will cover that as I vy to the j vz to the k. Okay, therefore it's a 3-dimension. This is a 2-dimension. We will cover that in the 3-dimension. Okay, this I and j and k refer to z, y and z. Now sorry, x. Okay, now this I refer to x, j refer to y, and k refer to the z. And how do we identify the magnitude of v? The magnitude of v, that means the vector of any object in a 3D form. In the 3D form, we able to see this object ax2 ay az2. That means we are trying to observe this in a bigger scale. We can see that as a kind of, we are placing that in this from original point of here. Can we see this object like this? Okay, it's a diagonal. Okay, we are trying to understand this is actually is a diagonal of any particular cube. or particular cube that we are identifying here. Therefore, this V, the magnitude of V basically is we are trying to identify the distance or the length of object particular vector in the diagonal form. Okay, now with this information we have done what we call unit vectors. Unit vector basically is the smallest building unit. Therefore, unit vector in a simple is the smallest unit, and it can be explained as a vector divided, okay, with the magnitude. Whenever we divide with this, we need to use a cap. To address the smallest unit block, the building block of vector, we need to use a cap here. Okay, now we will proceed to another. Okay, we will proceed to another component called unit tangent vector. Okay, unit tangent vector. Okay, unit tangent vector is one of the very interesting, whereby we can not only be able to monitor any particular object located in a space, be able to see the progress of, for example, a particular movement of any particles, for example, any objects. Therefore, this movement we can use a parametric method, and we can call it this as a ZK RU. Okay, I am referring the RU is a parametric representation, where the U in this case X represented with the 2U, and Y represented with the U23, Z represented with the 2U2 plus 5. For example, this is an example, I'm giving an example. Okay, this is basically is in a functions. Okay, it's a small functions. The X is a function of U. Okay, okay, this is a functional representation of X, Y, Z. Therefore, this is, we call it as a parametrizations. When we try to parameterize this, we are trying to see the movement of the object. Therefore, let's say this RU, XI, YJ, ZK representing this movement of a particular object. Let's say this is an object. Okay, it could be anything, it could be any particles. Okay, with that I can represent this in a one single parametric U. Okay, the I, U2, 3J, 2U2 plus 5K. That means now I have represented the whole component of X, Y, Z of coordinate system in the one representation called U as a independent variable. This independent variable can be a time, or it could be any other frequency or anything which is we can represent to identify the location of particular movement of the object. Okay, this I'll try to elaborate further on this. Okay, when I substitute the U, you able to see the movement of the object as this. Okay, you can see this in the representation of, if U are equated with the 1, I will get what I call it as the coordinate for, or the location of that object. Okay, I am able to monitor the co-location of this object here. Okay, step by step, you can see if U equals to 2, I am able to identify the object as this. Okay, some of you may ask, how am I getting this 2, 4, 7? It's a kind of just representation here. For example, here, when I say if u equals to 1, that means x equals to 2 times 1, I'll get it 2. Y equals to 1 equals to 3, I get it here 4. To represent the z, here 2, 1, 2 plus 5, therefore I'll get it 7. Okay, therefore you are able to identify the location of that particular object. 13, if I use the representation of what I call it as R1, R2, R3 and continuously. Therefore the object is moving using the parametric u, and once you substitute that with the certain numbers, then you can see the object, the movement of that object, okay, in a particular point. Therefore, is there any way that I can able to see the movement of this object, the movement or the what I call the horizontal movement of that object? Therefore, if I wanted to monitor or if I wanted to capture the horizontal movement of the object, we call it this as a tangent. As you all know, the particular point, when I start drawing one horizontal line touching that point, okay, we call it that as a tangent. Any particular point touched with the one horizontal line there, we call it this is a tangent. And the tangent can be identified, okay, you can see the tangent is varied in every movement. It's not the same in every location, in every point of that movement of that object. Therefore, is it possible for us to capture the detail of tangent of particular object? Therefore, one of the way to identify the object, in this case the tangent, unit tangent, is referring to r prime, magnitude to the r prime. Okay, how do we know why this is a r prime? How do we know this is a r prime? The simple way to address this is I able to give you one simple idea what is going on here, why this must be a r prime. Okay, why are we taking this okay, the equation of this ru, and we are doing derivation on that. Okay, when I try to use a derivation, as usual, this is a very common understanding, right? When if there is a one equation here, for example x2, when I start using a derivation of this function, this is basically is a tangent. But is there any other way to understand this logics of this tangent? Okay, now we try to capture these two information here. Okay, you see, I take an object of here from the r, from origin point r, and to the r2. When I see, let's say the thing, okay, the object, the particles moving through this line, and imagine this line is too small, very small, very small. When if it is a very small, then we able to monitor, okay, we able to monitor that as a dr, okay, dr, whereby we able to explain that as a dr to the dx, dy to the dj. Okay, and I able to capture this information as a dr. If it is a very small, okay, infinitesimally is a small unit, I able to capture this dr as a different from the tangent line. Okay, I able to capture the tangent line of the movement of the object through dr here. Okay, the dr can be a one of the smallest unit where we can capture the movement of that object. Therefore, in this case, dr, now we know why are we using a dr here. Okay, tangent, unit tangent is the smallest. I can put it here cap as well for just for the simplest identification. In order to identify the unit tangent, okay, we use r differentiation divided with the magnitude. Okay, now this is actually, we can call it this as a microscopic view. Okay, is to identify the tangent. Okay, now with this, can I identify the tangent unit? How to calculate the tangent unit? Okay, the tangent unit can be calculated with a very simple method. Okay, we just differentiate this. We just differentiate the r. We just differentiate. We get it here 2i 2uj 4uk. Okay, when we differentiate that, we will get it this. Therefore, is it possible for us to define what you call the tangent unit of that, or to calculate the tangent unit of this? I 2j 4k, taking the vector and divide the vector with the unit vector. Okay, unit vector. Therefore, this is how we able to get the smallest unit, okay, which is moving horizontally to that point. Okay, it's a horizontal to that point. That means we able to, when we say tangent unit is a in a simple way to understand, the tangent unit is the horizontal line progressing parallelly with the movement of a particular object. Okay, now with that, we have done what we call as a unit tangent vector. Okay, for some time, for mechanical or electrical electronic engineering students, sometimes they need to know more than unit tangent vector. They need to learn what they call it as okay, is that normal vector? Okay, normal. Okay, it's sorry, not a. This we call it that as a normal vector. Okay. Okay, we will take a small break. Okay, then I will explain what is unit normal vector.